In this lecture, we will extend what one might refer to as the standard parameterization of a line segment for curve fitting by Bezier curves for more than 2 points. First, let us review some facts about the parameterization of a line. Let P sub AB be a point on the segment between A and B. Then the vector AP sub AB should be a scalar multiple of the vector AB. T is a real scalar between 0 and 1. It represents the ratio between the lengths of AP sub AB and the vector AB. At t equals 0, the points P sub AB and A are the same exact point. As t becomes more positive, the length of the vector AP sub AB increases, so that when t is finally equal to 1, P sub AB and B are the same exact point. We can also say that the direction of the parameterization is from A to B. From this relationship between the two vectors, we are able to derive an equation for the coordinates of P sub AB. This vector corresponds to P sub AB, this to A, and this to B minus A. Reordering and regrouping the terms, we get P sub AB is equal to the quantity 1 minus t times A plus t times B. Let us extend this idea to include a third point, C. We will find a formulation for a smooth curve that goes in the general direction from A to B and then from B to C. Let P sub BC be on the segment between B and C. Suppose that the ratio between the lengths of the vectors BP sub BC and BC is also equal to t. Then we get an equation for P sub BC which is almost exactly the same as that for P sub AB. This corresponds to P sub BC, this to B, and this to C minus B. This leads to the equation for P sub BC. We will use P sub AB and P sub BC to obtain the eventual Bezier curve for A, B, and C. Take the segment between P sub AB and P sub BC. We take a point P sub ABC on this line segment to represent the Bezier curve. Suppose that the distance between P sub AB and P sub ABC divided by the distance between P sub AB and P sub BC is equal to t. Then using parameterization similar to these, P sub ABC is equal to the quantity 1 minus t times P sub AB plus t times P sub BC. We replace P sub AB by its parameterization and get this first part. And then do the same thing for P sub BC to get the rest of the parameterization. Multiplying things out and grouping things according to the different vectors. The first part is the square of the quantity 1 minus t times the vector A. Then we have 2t times the quantity 1 minus t times the vector b. Finally, we have t squared times c. Now we will show what the actual curve looks like. Starting at t equals 0, P sub ABC is the same as the point A. Sliding t along the interval from 0 to 1, the point PABC proceeds to move towards B, but it does not pass through B, but then moves on to C, and eventually merges with C when t is equal to 1.